बस Good morning, students. Is it audible to you? Is it clear? My voice is clear? Right. So, the last class yesterday we had discussed almost that atom chapter completed. So today we are going to be start another chapter, or we can say it's the under the modern physics only, which we call dual nature of matter, atom, and nucleus. These three together modern physics we call. So in that modern physics, in that last chapter or last topic. So before that, like drawback of Bohr model. Drawback of Bohr model. What are the drawbacks of Bohr model means? Basically, Bohr explain the different orbits, how the electron revolves around the nucleus, right? He got the different energy of electron energy levels or energy in particular orbit. Everything is explained, but he failed to explain the major drawback of the Bohr model. The major drawback of Bohr model is this model basically it's applicable only single electron atom. So this model exclusively applicable only for a single electron atom or hydrogen like atoms. Hydrogen like atoms only, right? Like single ionized hydrogen atom directly is applicable because single electron only present here. And helium, single ionized helium atom or double ionized lithium atom, like that. Hydrogen like atoms, that means hydrogen like atom means what? Single electron should be present, that is remaining electron should be ionized, correct? So this type of Bohr model exclusively applicable for this type only. So 2 electron 3 electron is there means it cannot applicable this model. This model is cannot applicable for such type of atom which has consist more than 1 electron. Okay, so major drawback it is applicable only hydrogen like atoms. Okay, so one by one points I will say, you just note down it. Okay, right. Drawbacks. First point, drawback of Bohr model. It is apply only H like atoms or single electron. atoms. Like example, you take hydrogen, helium plus, lithium 2 plus, and etc. Hydrogen like atoms only it can applicable. It cannot apply other atom. It is apply only for only H like atoms, single electron atoms, right? The first major drawback it is. Second one, electron is said it stay in particular orbit, it revolves around the nucleus. Electron revolves around the nucleus. Bohr said that electron revolves around the nucleus, right? So, but electron not only revolves around the nucleus, it also revolves around its own axis, like our Earth. Earth revolves around the sun. Also, it is rotate about its own axis. Rotate about its own axis. Similarly, is said only the electron revolving around the nucleus. So it is not moving, or it is rotation is not doing, or its own rotation is not doing. So Bohr said that there is no rotation about the electron, but only revolving around the nucleus. So, but practically, electron not only revolves around the nucleus, it also rotates about its own axis, or like Earth rotate about its own axis and revolves around the sun, like that. But it did not explain the rotation of electron about its own axis. So they said it is stationary. Electron is stationary. Electron is stationary, but it rotates about its own axis, about its axis. Bohr said that it is stationary, but it is rotate about its own axis. The second drawback, that is, it did not given any explanation about the rotation of the electron. Okay, and third one is like it did not explain about intensity of spectral lines. That simply they said photon energy will come and wavelength this much, frequency this much, or energy this much. Photon of energy when it is electron jump from higher energy to lower energy level. So there is a h nu amount of energy will produce, and that h nu will be, we can calculate, or energy you can calculate, frequency you can calculate, or wavelength you can calculate, corresponding to the photon emitted by electron when it is jump from higher to lower energy level. But it did not explain about intensity of spectral lines. That is, what kind of intensity? We know intensity is a what? Number of photons, right? So it did not explain about intensity. Not given explanation to intensity of spectral lines. Intensity of spectral lines. Clear? So it is applicable only for hydrogen like atoms, like single electron atoms, and the electron said that it is stationary, but it is rotate about its own axis. Not only revolves around the nucleus, it also rotate about its own axis. Not given explanation to the intensity of spectral lines. Clear? So these are mainly drawbacks. Some are also there that you can just mainly this much only. Okay. And like Zeeman effect, Stark effect not explained. That chemistry you may study that one. What is that? But mainly this one. And apart from that, see, actually the Bohr they given the energy of electron and etc. that is given on the basis of assuming electron stationary while revolving around the nucleus. We assume that electron stationary while revolving around the nucleus, but practically it is rotate about its own axis, right? So based on that, there is a slight difference or effect of nucleus mass. Effect of nucleus mass. Okay. So what is nucleus mass? Basically, nucleus, this one, right? This is a positive charge nucleus, and around it electron is revolving in particular orbit. Actually, what will happen generally, this nucleus also rotate and electron also rotate. Generally, they revolve around the nearly their center of mass. They revolves around their center of mass only. COM we call. So this is revolves around this center of mass and this is revolves around this center of mass. But in front of nucleus mass, electron mass almost negligible. Electron mass almost negligible. So due to that, the center of mass is very close to nucleus only present, because center of mass located towards the heavier mass. Towards the heavier mass. So towards the heavier mass means, so this is close to the nucleus only exists. So practical situation, we consider it is revolves around the nucleus because the center of mass is close to nucleus only. But in generally, I want to say nucleus and electron, they revolve around about their center of mass. About their center of mass. The effective mass in this case we can take effective mass, or it is also called reduced mass. Reduced mass, that is denoted by mu. It is simply mass of nucleus into mass of electron by mass of nucleus plus mass of electron. This is reduced mass we call. And with help of this reduced mass, energy of electron we can write directly. Energy of electron, E, we can write generally minus 13.6 Z square by N square, right? General. But apart from that, because of the mass, of the effect of mass of the nucleus, due to that reduced mass, we'll consider here mu by M will come. Mass of electron, M is the mass of electron, and mu is a reduced mass. Mu is a reduced mass. So this is final expression for, even if you take into consideration of mass of effect of nucleus mass, then the energy of electron in any particular orbit of any particular atom will be minus 13.6 Z square by N square mu by M. Electron volt only. Minus 13.6 Z square by N square into mu by M, where mu is the reduced mass, that is Mn, mass of nucleus into mass of electron by nucleus mass. N stand for nucleus mass here. Capital M, I'll write. So mass of nucleus into mass of electron by mass of nucleus plus mass of electron. That is reduced mass will take there, mu by M. Generally reduced mass, if you remember in collision there also both the springs are moving like this. In that also we'll consider reduced mass. In SHM also reduced mass will take. Like that one, reduced mass is a product of masses by sum of masses basically. Mu by M. Just remember this. If rarely they will ask, rarely, if the effect of nucleus, if the question is given, what is the energy of electron in a particular orbit of particular atom, if you take into consideration of effect mass of nucleus. So at that time they will give the mass of nucleus, they will mention. So based on that we need to calculate what reduced mass and substitute there. Clear? This is. And one more point regarding that. This is noted drawbacks of the Bohr model. Look here. For example, okay. So an electron is jumping from this to this and releasing one photon, lambda 1 wavelength. Assume that, assume. And one more electron is jumping from this energy level to this, which is releasing and photon of 8 lambda 2 wavelength. Assume it. Okay. Now there is another electron which is jumped from this energy level to directly this. Directly here it jump and release a photon of wavelength lambda 3. Look here. From this energy to this energy level, lambda 1 from this to this lambda 2. Okay. Otherwise, I can take E1, it is E2 or E3. So it jumps in that way. Assume that. Okay. So electron is jumping from this energy level to here, releasing a photon of lambda 1 wavelength. Electron jump from this energy level to this energy level, releasing a photon of lambda 2 wavelength. And finally, it is jump from this energy level to this energy level. Electron, in all the situation, electron only it is jumping and release a photon of lambda 3 wavelength. Okay. Then relation between this lambda 1, lambda 2, lambda 3 becomes, how this relation will come mean, 1 by lambda 3 will be equal to 1 by lambda 1 plus 1 by lambda 2. The relation between lambda 1, lambda 2, lambda 3, because lambda 1 is releasing from here to here, lambda 2 is releasing from here to here. Directly addition won't possible, because we know 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Correct? If it is hydrogen atom, or z square is there, another atom is there. So z r into z square 1 by n1 square minus 1 by n2 square, that is equal to 1 by lambda. Correct? So that, based on that, apply this and you will get the exactly relation 1 by lambda 3 is equal to 1 by lambda 1 plus 1 by lambda 2. Because here here relation you apply same, lambda 1 by lambda is equal to z square r 1 by n1 square minus 1 by n2 square. And here you apply, then this you apply. Then you will exactly the when you apply this one, you will get sum of these two only. Sum of these two only. If you want, you can verify that by apply that formula, but you will get exactly 1 by lambda 3 is equal to 1 by lambda 1 plus 1 by lambda 2. Sometime they will ask, what is the wave number emitted from here to here? If the wave number emitted here to here is 2 or 3 like this is given, so some of them we have to do it, reciprocals. Clear? So this is about atoms. Okay. So the practice questions we'll do in the doubt session. I'll told to do the questions from module, right? So that we will do it. So concept, this is atom completely. Note down. Any doubt here? Yeah, that part yesterday I told, right? Nuclear radius and that will going to be discussed in nuclei chapter. We will going to be start it now. Don't worry. Okay. Atoms chapter is completed. Atom chapter is completed. Now we are going to be start another chapter under modern physics branch. That is nuclei. Nuclei. According to your IP board, nuclei is another chapter only. Okay. For Sunday exam only, atoms and dual nature. Dual nature 80% and atoms 20% it will come. Okay. Right. Next. Nuclei. So nuclei, basically nuclei. So we have found that in the atom chapter I told there are different atomic model is given about the structure of the atom. So in that Rutherford alpha particle scattering experiment, they found first what is nucleus. What is nucleus and where it is located and what is its charge. That's it. Correct? So like nuclei chapter, basically in this nuclei chapter, first, we have discussed something related to matter waves, uh, nature of particle nature and wave nature of dual nature we studied. After that, what is atom, structure of atom, what is different energy levels in atom chapter. In nuclei chapter, what we are going to be concentrate means, especially we concentrate in atoms, we discuss about the electron only. Electron energy, electron orbit, electron radius, velocity, etc., etc. Completely about the electron. But now in nuclei chapter, we are going to be concentrate on nucleus. What is nucleus? What is its size? What is its density? What it contain inside the nucleus, right? So how it is formed nucleus? What are the kind of reactions are there, right? What are the stable nucleus, unstable nucleus? So generally unstable nucleus undergo disintegration, that is decays we call. What are different types of decays we have? Unstable nucleus, generally disintegration takes place. Disintegration means break up into lighter nucleus. So what are kind of nuclear reactions like nuclear fusion, nuclear fission, right? And radioactivity law, how the disintegration process is taking place, right? So mainly here we have to focus two things. One is calculation of binding energy by using mass defect. Second thing is law of radioactivity. Law of radioactivity. Most of the questions will come from this area only, from nuclei. Law of radioactivity and this what do you call mass defect and binding energy. So we'll start that. Okay. Nuclei. Basically, nucleus of an atom or element. Nucleus. So nucleus basically, it is a center part of the atom and occupied very small space. Very small space. Very small volume. Small space or small volume. Okay. So you can say that center point of atom as very small volume or space, whatever you can say. Clear? Very small volume it has, right? Next. So this center part has very small area, small volume. So generally nucleus we consider spherical body only, sphere. So it considered as sphere only. Considered as sphere. Right? So sphere we know, sphere volume is what? Volume of sphere is what? Volume of sphere we know. Volume of sphere is 4 by 3 pi r cube, where r is the radius of the sphere, nothing but radius of the nucleus we call. Now this nucleus consists, okay, nucleus consists of positive charge, or it consists of two types of particles. Two types of particle consist of protons and neutrons. Protons and neutrons. Nucleus consists of two types of particles named as protons and neutrons. So these together, protons and nucleus together we call, called the particles which are present inside the nucleus, or the nucleus consists kind of particles called nucleons. Called nucleons. Nucleons. So Inside the nucleus, protons and neutrons will be present. Proton and neutrons will be present. But this proton and neutron together, total number of particles inside the nucleus, protons, neutrons will be present. Total number we call nucleons. So nucleus consists of nucleons. Clear? Very good. Next, protons we know, proton as positive charge. Positive charge. But neutrons as chargeless, or neutron is neutral particle. Neutral particle. Electrically neutral. Neutral particle means electrically neutral. So neutron has no charge. It has no charge. Electrically neutral. No positive charge, no negative charge. That means electron, it will, sorry, not electron, neutron. Neutron, when it is passing through electric field or passing through magnetic field, it won't deflect any direction. It won't deflect any direction. Clear? So because it has no charge, so due to that there is no electrostatic force and there is no charge, so there is no magnetic force also. Q will be sine theta, Q into E, both are zero because Q will be zero. So neutron has no, it does not experience any force due to electrostatic field and magnetic field. So electrically neutral. So two types of particle inside the nucleus, one is protons, other one is neutron, and total number of particles in nucleus called nucleons. Now you see inside the nucleus protons are there as well as neutrons are there, but protons possess positive charge, right? So nucleus consists of charge. Overall nucleus is considered, it is a combination of protons and neutrons. So total charge of nucleus you want to say is a positive charge, right? So this is already we said in Rutherford experiment only. So it has positive charge. Even neutron has charge less, but proton, due to proton it has a charge, positive charge. Okay. So symbol of neutron, basically, sorry, symbol of nucleus. Symbol is, generally let us say there is a X element or X nucleus. Number of protons present in the nucleus. Number of protons present in a nucleus. It's called atomic number. Number of protons is nothing but atomic number. So atomic number Z denoted by Z, and total number of nucleon number. Total number of nucleons number. Total number of nucleons. Total number of nucleon means sum of protons and neutrons. Sum of protons and neutrons. So that is basically mass number we call. Nucleon number or mass number we call. ZA. X is a nucleus name, element name. So X, Z means number of protons represent, A represent number of nucleons, not neutrons, number of nucleon, nothing but combination of protons and neutrons. So here Z represent what? Atomic number, correct? Equal to protons number. Correct? Atomic number is nothing but protons number only. Then A, basically mass number, and that is equal to nucleon number. Nucleons number. Total number of nucleon, that is mass number only. That is sum of protons as well as neutrons. Then atomic number, nothing but proton number. A is a mass number, is nothing but nucleon number. Then inside the nucleus, neutrons as well as protons are there. Neutrons as well as protons are there. Okay. Then we can write total number of neutrons present. So this is total number of protons plus neutron. This is only proton number. Then what is neutron number? So number of neutrons is equal to A minus Z, because in A neutrons are there, protons are there. How many protons are there means Z number are there. So A minus Z if you do, that will give number of neutrons. Number of neutrons. Clear? Okay. Z is an atomic number, A is a mass number or nucleon number. If you say what is the charge of the nucleus, because I said it has positive charge, right? So what is the charge of a nucleus? Charge of a nucleus means, look here. Charge of nucleus. Charge of nucleus basically, proton has positive charge, neutron has no charge. So charge is consists or charge of nucleus is equal to total positive charge of protons. Total positive charge of protons. So how many each proton has some charge? 1.6 into 10 to the power of 1.6 into 10 to the power of minus 19 coulomb. Each proton has that much of charge. Then how many protons nucleus consists? Z number, that is atomic number. What is atomic number of nucleus? So that equal to proton number will be present. And each proton has 1.6 into 10 to the power of minus 19 coulomb charge is there. So that means Z number of protons are there. So total charge will be what? Charge of proton into total protons. Correct? So charge of nucleus, Z into E plus Z into E. Clear? Plus Z into E. Plus represent positive charge. E represent 1.6 into 10 to the power of minus 19. Z represent atomic number. E is equal to 1.6 into 10 to the power of minus 19 coulomb. Clear? So Z, if you multiply with Z, that will give the total charge of nucleus. Similarly, mass of nucleus. What is mass of nucleus? Mass of nucleus means, we know neutron has mass, proton also has mass. Proton and neutron both has a mass, right? But exactly if you take proton mass slightly smaller than neutron mass, or neutron mass slightly greater than proton mass. Okay, is it clear? That means this number of protons are there in this nucleus, this number of neutrons are there in this one. Nothing but these many nucleons are there, right? So nucleon is nothing but, it is maybe a proton, it may be a neutron that is present inside the nucleus. Proton also nucleon we call, neutron also nucleon we call, because they are present inside the nucleus. Correct? So A is a mass number, nothing but nucleons number. Then how many number of nucleons are there, and mass, that number into mass of each nucleon. Mass of each nucleon. Right? So multiply, then we will get the total mass of nucleus. See, mass of each nucleus, clear? Mass of each nucleus, sorry, mass of each nucleon into nucleon number. How many nucleon number there? A into each mass of nucleon, right? So that mass of nucleus we can write, look carefully. Mass of nucleus, M. This can be written as, how many nucleons are there? A. Each mass of nucleon, let us say small m. So I can write A into, or M into A. M into A. Where small m is mass of, or we can say average mass of protons plus neutron. Average mass of one nucleon, nothing but proton and neutron. So proton mass plus neutron mass, and average of that, average of proton and neutron mass, that is called small m. Nothing but each nucleon mass will get average mass of nucleon. Nothing but proton is slightly smaller than neutron mass, then average, if you take average on an average, each nucleon mass will get. So that's the reason small m I wrote average of proton and neutron mass. Average mass of proton plus neutron mass. Okay. So average means proton mass plus neutron mass by 2. Proton mass plus neutron mass by 2. Okay. Mass of nucleus m into a. M is the mass of each nucleon or average mass of proton and neutron into a, because how many nucleons are there? M into a. M into a is the nuclear number, total mass of nucleus. Number of neutron a minus z. Charge of nucleus, proton charge will provided by protons only, that is atomic number z into a. Positive charge E is 1.6 into 10 power minus 19 coulomb. Clear? So this is just basic representation of nucleus, how to represent, what are the terminology in that. And this neutron, basically neutron, I said neutron consists of neutrons, right? Neutron is chargeless, neutral electrically. It has a mass slightly greater than proton mass, and it is discovered by neutron, discovered by Chadwick. Neutron discovered by Chadwick scientist. And nucleus, there is a center point of the atom named as a nucleus. It has very total mass of the atom 99% of 9%, 99.9% of mass of atom concentrated the center. I call it as a nucleus, right? So that is found by the Rutherford. Nucleus found by Rutherford in alpha particle scattering experiment. Rutherford found the nucleus, but neutron discovered by Chadwick. Neutron discovered by Chadwick. Okay, so this note down. So we'll discuss next what is that. Is it clear? Just a representation of nucleus. Any doubt in that? Here A is not a mass of nucleon. A is the number of nucleons. Number of nucleons. Clear? How many total number of protons and neutrons present inside the nucleus? That represent A. Mass number it is. Mass number. Mass is provided due to proton as well as neutron. Right, right? Mass is provided due to proton as well as neutron. That is the reason mass number it is called. Mass number. It's not mass. It is a just mass number. How many mass particles are there? Indirectly we can say how many mass particles are there inside the nucleus. These many mass particles are there. Nothing but mass number, not a mass. Mass of the nucleus I wrote here. Mass of nucleus is equal to m into a. Suppose there are 3 particles are there. Each particle 1 gram mass is there. So total mass is how much? 1 gram each particle into 3 particle. 1 into 3. 3 gram will get. So similarly, each particle or each nucleon mass is, or average mass of neutron proton is m into total number of nucleon how many? A. So total nucleus mass is this much. Don't consider A itself is a mass. No, it's a mass number. That is the atomic number or proton number. Clear? Yes, A is a number of nucleons or mass number. Right. So this is basic representations or terms related to nucleus. Let us rediscuss. We have got what is mass of nucleus, and we have got what is the number of neutrons, protons, and nucleons also. Let us rediscuss what is it, the size of radius or size of nucleus. Okay, look. Size of nucleus. Size of nucleus. Size of nucleus means the size total. Basically, already I told nucleus is a spherical shape or sphere. It is sphere, right? So size means volume, we can say, right? Volume, radius, surface area, like that. Okay. So size of nucleus. Basically, experimentally they found it. The radius of the sphere of the nucleus, or nucleus we consider as a sphere, okay? The radius of that nucleus radius of the nucleus, okay, is directly proportional to cube root of mass number. Cube root of mass number. So they said it, radius of nucleus, radius of nucleus, that is R, it is directly proportional to cube root, that means a power 1 by 3. A is a mass number. A is a mass number. So furtherly this can be written as, R can be written as some constant, proportionality cancel out some constant, that is R naught I am taking, into a power 1 by 3. So here a power 1 by 3, A is, we know, mass number or nuclear number of nucleus, and R naught is constant, and that value is approximately 1.2 into 10 to the power minus 15 meter, or 1.2 Fermi meter. 10 to the power of minus 15 is Fermi. Remember, in nucleus size, generally nucleus radius, nucleus, whatever the size, volume, radius, will represent in terms of Fermis only. Fermi means 10 to the power of minus 15. Okay, Fermi means 10 to the power of minus 15. Remember, 1 Fermi is 10 to the power minus 15 meter. Remember. Okay, 1 angstrom already we know, which is 10 to the power of minus 10 meter. Right? Fermi, 10 to the power of minus 15 meter. Angstrom, 10 to the power minus 10 meter. So that is that R naught is constant, 1.2 Fermi. Fermi, and 1.2 10 to the power minus 15 meter. Okay. So this is radius. Radius only. So we consider nucleus as a sphere. Nucleus as a sphere. So that means I can say sphere as a surface area. Yes. Sphere as a surface area. Yes. Sphere as a surface volume also. Volume it is there. So let us see what is surface area and volume. Surface area of nucleus. Surface area of nucleus. So let us say surface area, let us S, because A already atomic mass number is there. Na? So that S I am representing. Surface area sphere is what? 4 pi r square. 4 pi r square. Correct? So can I write S is equal to 4 pi, R is R naught a to the power 1 by 3. So R naught a power 1 by 3 whole square. So this I can write 4 pi R naught square into a power 2 by 3. But 4 pi constant, R naught square is constant here. So overall I can write S is directly proportional to 4 pi R naught square only, that is anyway constant only. So variable it is a power 2 by 3. So S is directly proportional to the surface area of the nucleus, is directly proportional to a power, that is mass number, a power 2 by 3. A power 2 by 3. Okay. Similarly, volume. Volume of nucleus. V. What is volume? Volume is, we consider nucleus is a sphere. So V is equal to what? 4 by 3 pi r cube. So V is equal to 4 by 3 pi r naught a power 1 by 3 whole cube. Correct? R cube I am saying. So again if I cancel it, 4 by 3 pi r naught cube into a power 1 by 3 whole power 3. 1 by 3 whole power 3. 3 cancel, a only will come. So 4 by 3 pi r naught cube anyway constant only here. So we can write V, volume, directly proportional to a only. Volume directly proportional to a. Volume directly proportional to a. Yes or no? So we have got a radius directly proportional to a power 1 by 3. Surface area directly proportional to 2 by 3. Volume directly proportional to a only. That is Mass number is greater. Greater mass number, greater volume or greater size. Lesser mass number, lesser size of the nucleus. Simple. Clear? Volume is directly proportional to mass number, which has heavy mass number is there. So definitely it has size is more. Lesser mass number is there, size is less because V is directly proportional to A. Is it clear? Radius, surface area, volume of nucleus. Clear everyone? See once, any doubt you ask me? Boys and girls, any doubt? Tell me. Related to size of the nucleus, the question will ask here only. Now we will discuss density also, but before that, what is radius? Mainly they will ask ratio only. Ratio. Ratio means that's the reason I wrote proportionality. R depends upon what, S depends upon what, V depends upon what. S is surface area, right? What is S here? S is surface area. V volume, right? So surface area depends upon A power 2 by 3, volume depends upon A only, radius depends upon A power 1 by 3. Any doubt? Tell me. R naught is a simple constant only. I have given R naught value 1.2 into 10 to the power minus 15. Everywhere I wrote in surface area or volume, R naught value same only. So, but anyway, 4 pi and R naught constant only. This quantity totally constant. So, surface area depends upon A only. Whatever the mass number you take, this value remains same. So, surface area clearly depends upon A power 2 by 3. Similarly, volume depends upon A only. Clear, na? See, volume and see, volume is what we have considered, or I said in the before that, nucleus is considered as a sphere. Sphere radius R, that is R radius of the nucleus. I said R is equal to R naught A power 1 by 3. Then volume of nucleus, nothing but volume of sphere. So volume of sphere 4 by 3 pi R cube. So R is the radius of the sphere, radius of the nucleus, which is R naught A power 1 by 3. So that R naught A power 1 by 3 I am writing. In place of R, I replace R naught into A power 1 by 3 whole cube it is. Then 4 by 3 pi R naught cube, A power 1 by 3 is there, whole power 3 is there. 3 cancelled out. Then A only. A power 1 by 3 is there and whole power 3 is there. So this 3 cancel out. Remember this A power 1 by 3 only, R naught not power 1 by 3. Simply R naught only, R naught into A power 1 by 3 it is. So that's the reason only the 3 cancel for A only. Now 4 by 3 pi, R naught anyway constant and 4 by 3 pi is also constant. So V depends only on I. So V is directly proportional, A. V directly proportional to A. V is a volume, S is a surface area. Clear now? Any doubt? Yes or no? Tell me, is it clear now? Volume of that one? Right. Now we have got radius, we have got volume, and we have got surface area. Let us discuss what you call density. Very important one. Look here, density. Density of nucleus. Density of nucleus. Look here. Density of nucleus, rho. Density is a rho, right? Yes. Rho. What is density? Mass by volume. Mass by volume. So density of which one we are defining? Density of nucleus. So normally density is equal to mass of the object by volume of the object. So here density of nucleus we are defining. So mass of nucleus by volume of nucleus. So volume of nucleus we have got. This is volume of nucleus. Correct? And we know just before that I said mass of nucleus also I have said. So that means we have a mass of nucleus, we have a volume of nucleus. Just divide, we'll get a rate density. So density is equal to mass of nucleus by volume of nucleus, right? So mass of nucleus, if you remember I wrote average mass of nucleon, m into total nucleon number, that is A, mass number, correct? So can I write mass of nucleus, which I can write capital M by V, that I can write small m into A by V. Okay? Yes or no? Yes. Now let us look here. M, mass of, average mass of nucleon, okay, or E, average mass of proton. So M average, the M approximately, M is equal to average mass of proton plus neutron, right? Neutron. This is approximately will get 1.66 into 10 to the power minus 27 kg will get approximately. Approximately that this M value will get, because proton mass we know 1.67 into 10 to the power of minus 27 kg. Neutron mass slightly greater than that, like 1.69 into 10 to the power of minus 27. So average, on an average if you take this much 1.66 into 10 to the power minus 27 kg will get. Okay. Now look here. Now M I know A. Then volume. We will substitute it. What happened we'll see. Look here. So from here, according to rho is equal to M. M is 1.66 into 10 to the power of minus 27 kg. A only atomic mass number divided by V. V is what? Volume. 4 by 3 pi R naught cube into A. So I am writing 4 by 3 pi R naught cube into A. A cancelled. Atomic mass number cancelled. Then what is left here? This 3 will go up, right? So that is 3 into 1.66 into 10 to the power of minus 27 divided by pi is 3.14 into 4 is there. R naught cube. R naught value is what? 1.2 into 10 to the power of minus 15, right? So I am substituting that. 1.2 into 10 to the power of minus 15 whole cube. Then furtherly I am simplifying this one. 3 into 1.66 into 10 to the power of minus 27 by, this is 12, 14 4s are 56, right? So it is nearly 12.56 into 1.2 whole cube into 15 whole, 10 power minus 15 whole cube means 10 to the power of minus 45. Clear? 45. Now look here, minus 27 minus 45. How much left? Minus 27 minus 45 cancel out. How much will come? Minus 27. So here 18, right? 10 power minus 18 will come. No. Yes, 10 to the power of minus 18. Because 8 means 35 plus 45, right? 10 to the power of minus 18. So minus 18 is left here. So now furtherly if you simplify, what will get? Look here. Furtherly you simplify, this 10 to the power of minus 18, it will go up. So this is become 3 6 18, 3 6 18, that is 19, 3 3 4, 4.98, 98. into 10 to the power of plus 18. This is come upward plus 18. And denominator we have 12.56 into 1.2 whole cube. See, look here, this is rho. In this one, anything variable is getting, any mass number, atomic number, neutron number, anything is there in that finally? Just numbers only. If you calculate, I will say that final what is the answer. So what is that? 4.98. So 1.2 into 1.2, 1.728, that is 1.2 whole cube is 1.728. 21.7 totally, denominator 21.7. The denominator is 21.7. Numerator is 4.98 by 21.7 into 10 to the power of 18. So this is simply we can calculate 4.98 divided by 21.7. So nearly it is coming 0.229 into 10 to the power 18. So this is approximately we can write it as 2.3 or 2.3 you can write. This is 2.3 nearly into 10 to the power of 17 kg per meter cube. Finally, look here. Kg per meter cube. 2.3 into 10 to the power of 17 kg per meter cube. Now, everybody look at the board. Now tell me, density of nucleus we have got 2.3 into 10 to the power of 17 kg per meter cube. 2.3 into 10 to the power of 17 kg per meter cube. That means it is in the order of 10 to the power of 17 kg. 2.3 anyway constant. 10 to the power of 17 kg order. 10 to the power of 17 kg meter cube order. Now, can I say what is the ratio of, simple logical question I am asking, look based on it. The ratio of density of helium to the carbon. Tell me, what is the ratio of density of helium to the carbon? Helium nucleus to carbon nucleus. The density ratio of helium to the carbon. What is the ratio of that? You know, helium atomic mass number is 4, that is A is 4, and carbon is 12. Tell me, what is the ratio of density of helium to carbon? 4, helium mass number 4, carbon mass number 12. Tell me, what is the density ratio? Density ratio. Simple question only, not difficult. Tell me. Everyone answer it. First of all, tell me, density is clear, everything? Any doubt in the density? Clear na? Nuclear density or density of nucleus. Is it clear? Finally, we got 2.3 into 10 to the power of 17 kg per meter cube. So what is the ratio? It is 1:1 only, because final density formula, in final density formula, do you have any atomic number here? No. Do you have any mass number in that? No. Any variable is there? No. See, 2.3 into 10 to the power of 17. It's a just constant value. It is does not depend upon mass number or atomic number, whatever you can say. It's just simply constant. Whatever the nucleus you take, whatever the nucleus, its density constant. Whatever the nucleus you take, its density constant, it is in the order of 10 to the power of 17 kg per meter cube. 10 to the power of 17 kg per meter cube. Whatever the mass number you take, ratio of two nucleus density is 1:1 only. Because same density only. Both the nucleus have same density irrespective of their mass numbers. Irrespective of their mass number. Clear? Is this point is clear, everyone? Yes or no? That one point you write down there. Everyone, after the density noting, you write down. Write down. Density of nucleus is constant. Density of nucleus is constant. Density of nucleus is constant and does not depend upon, mass number or atomic number. It does not depend upon mass number or atomic number. Remember that point is very important. Density of nucleus is constant and it does not depend upon mass number and atomic number. So there is no dependency on A as well as Z. Whatever the value of A you take or Z you take, it will have nucleus. Two different nucleus will have same density. Two different nucleus will have same density, even the mass numbers are different. Because mass numbers are different, even though mass numbers are different, so A cancelling out. Denominator volume is there, numerator mass is there. You know, mass is also directly proportional to mass number and volume also directly proportional to mass number. So numerator mass number, denominator mass number of any nucleus you take, it will cancel out only. So finally constant only will get. Is this point is clear, everyone? Yes or no? Clear? Density directly proportional to mass, inversely proportional to volume. So, but mass also depends upon atomic mass number. Volume also depends upon atomic mass number. That only explained just now. This A cancel out. Correct, na? So cancel out. So rho is independent of A. Independent of A. Clear? Right. Let us we do some numerical question based on this concept of size of nucleus. Look here. So simple question I'm asking. The ratio of size of nucleus to size of atom. Size of nucleus to size of atom. Ratio we need to calculate. The ratio of size of nucleus to size of atom. So options I'm giving. Option is 1:10 to the power of 15. B option is 10 to the power of 15 is to 10 to the power of 45. Sorry, 10 to the power of 3. 10 power 1. C option is 10 to the power of 15 is to 1. D option is none. Tell me, Calculate. Simple. Size of nucleus to size of atom. Size of nucleus. Size means volume. Size means how much bigger size, smaller size means size means volume. Indirectly ratio of volume of nucleus to volume of atom. Indirectly. What is the answer? The ratio of size of nucleus to size of atom. We know atomic radius is R directly proportional to R in the order of because basically atomic radius atom A, let us say atomic radius in the order of normally proportional to 10 to the power angstrom. In angstrom will come -10 meter, and nucleus radius Rn I am writing directly proportional to 10 to the power of -15 meter. Correct? So if you take size of nucleus to size of atom, right? So volume of the nucleus, that is 4/3 pi Rn cube by 4/3 pi Ra cube. That means proportionality ratio they want to calculate. So anything this will be cancelled out. So it will be come out to be how much it will come? Nucleus 10 to the power of -15 whole cube by 10 to the power -10 whole cube, which is 10 power -45 by 10 to the power of -30. -30 -45 cancel. So -15 will be left. So -15 means numerator -15 is there. Denominator how much it will come? So this I can write here 1 upon 10 to the power of +15, or it can be 1:10 to the power of 15. So which answer is correct? A. Clear na? Size of nucleus to size of atom is 1:10 to the power of 15. Obviously size of atom is greater because radius of the atom is 10 to the power of -10 meter. Then radius of the nucleus is 10 to the power of -15 meter. So radius is much more greater than the radius of the nucleus. Atomic radius is much more greater than the radius of the nucleus. So obviously size also much more greater. Clear no? So that is 1:15. 1:10 to the power of 15 size of nucleus to size of atom. Clear? Is this question is clear, student? Now one more question, you see. One more question. Okay. The radius of aluminium 27 is 3.2 Fermi meter. Fermi. Okay. Find the radius of copper 64. Simple question only. Radius of the aluminum given. Radius of nucleus of copper we need to find out. Radius of aluminum they given. Radius of copper we need to find. So radius of copper we need to find, radius of aluminum given. That means we need to calculate first ratio of radius we calculate. Then one ratio we know, radius we know, other radius automatically we can calculate. So first we know that radius is directly proportional to a power 1 by 3. A is the atomic number. Aluminum atomic number 27, copper atomic number 64 they give it. So that means we can write here R aluminum by R copper will be equal to a power of aluminum by a power 1 by 3 of copper, right? So can I write atomic number of aluminum is 27 whole power 1 by 3 and copper is 64 whole power 1 by 3. Correct? So this can be written as 27, I can written as 3 square. 3 cube 1 by 3. 64 I can write 4 cube 1 by 3. So 3 cancel, it will be 3 by 4. The ratio of aluminum radius to the ratio of copper, we got it as 3 by 4. That implies from their copper radius we can write cross multiply 4 into radius of aluminum by 3. 4 into radius of aluminum by 3. So this can be written as 4 into radius of aluminum is given 3.2 Fermi. So answer will come in the Fermi only, 3.2 by 3. Okay. So nearly how much it is? So that you can calculate, right? So 4 into 3.2, 12.8 by 3. 4.26. So nearly it is 4.26 Fermi meter, radius of copper. Understood, na? Process you understood. What the radius of aluminum they given, radius of copper they want to calculate. For that, first of all, ratio of radius will calculate. Then only automatically will get it. Clear? A is number of nucleon. Z is atomic number. So 27 is what? Atomic mass number only, nucleon number only. 64 and 27 are atomic mass numbers. Mass number, nucleon number. So one more question you see. Atomic mass you not consider. It is a mass, just now I am saying repeatedly. A is a mass number. Means mass of total, mass of nucleus you want to calculate A into M, each mass of nucleon. A is not atomic mass. Atomic mass number or simply mass number. Terminology, remember that. A is not atomic mass. It is an atomic mass number or simply nucleon number or mass number. Clear? Then one more question you see. One question you see. Calculate the mass number of that nucleus whose radius is whose radius is half of the radius. I am writing C. Example, find the mass number of nucleus whose radius is half of radius of germanium 72. Germanium 72 mass number they given. Clear? Find the mass number of nucleus whose radius is half of the radius of germanium radius. So germanium radius, how much it will be present? In that half of the radius, that nucleus we have, that nucleus mass number we need to calculate. So first of all, question is clear, everyone. We need to calculate the mass number of that nucleus whose radius is half of the radius of the germanium. Half of the radius of the germanium. Suppose germanium radius is R you take. Then that nucleus mass number we need to calculate is R by 2. Yes or no? Germanium radius is R if you consider. Then the whatever you want to calculate the mass number of nucleus, that radius is R by 2 because half of that is given. So what is the mass number of that nucleus we need to calculate? So simple question only. Look here. Let radius of germanium or GE 72 is 2R, let us consider, because R by 2 it will better calculation. 2R implies radius of that nucleus which we are going to be calculate the mass number. Nucleus will be R because half of that value R. You can take this is R by 2, but there 2R and R. Or if you confuse, I will take R only because then even R half of right? R by 2. Then mass number they want to calculate. So we will take the ratio. So what ratio? Nucleus ratio to germanium ratio will take. Clear? So I am taking this is R1 and I am taking this is R2. Correct? So we know that R is directly proportional to A power 1 by 3. So R1 by R2 will be equal to A1 by A2 whole power 1 by 3. Correct? Yes or no? Whole power 1 by 3. So now I can write now R1 R, R2 R by 2, R by 2, that is equal to A1. A1 means germanium because R1 we consider for germanium, so R2 consider for nucleus. So A1 means germanium 72 by A2, A only, that we need to calculate 1 by 3. So this 2 will RR cancel, 2 will go up. 2 is equal to 72 by A whole power 1 by 3, correct? So cube root on both the side. Both the side cube you do. So what will happen? 2 to the power 3 is equal to 72 by A because cube root will be cancelled out. So finally A is equal to 72 by 2 to the power 3. And we know 72 by 2 to the power of 3 is 8. So which is 9. 8 by 72 by 8 is how much? 8 9 is 72, right? 9. That is the answer. Question is clear, everyone? Any doubt? Simple only. The radius of that nucleus which is half of the radius of the germanium. So what will be its mass number? Because mass number of one germanium they given. Radius ratio if you take, ratio of mass number will come. So that is substituted there. Any doubt, student? Clear? So this is uh, size of the nucleus, like radius, like surface area. Surface area also ratio, if they ask, we can calculate. Surface area ratio is what? S1 by S2 is equal to A1 by A2 whole power 2 by 3. Volume ratio, V1 by V2 is equal to A1 by A2 directly, right? So in the coming classes, some more question will do based on this. So this is about size of the nucleus. In the next class, we will discuss what is mass defect and binding energy, that we'll discuss. Okay. Then before that, basic terminology like isotopes, isobar, isotones, you know, I think. Isotopes means the nucleus which has same atomic number, different mass number. 1H1, 1H2, 1H3, like that. Isobar means the elements are nucleus which has same atomic mass number but different atomic number. A is same, mass number is same, but atomic number is different. Proton number will be different. So that like 1H2, 1H3 and helium 2, 3, like that. Isotone means what? A will be different, Z will be different. That is mass number different, atomic number different. But the different neutron number will be same. Neutron number will be same. Those are called isotones. Tone means isotones. Neutron same. Neutron number same. Isotopes. Proton number same. That is Z is same. Isobars. A is same. Mass number same. Clear? So if you want, tomorrow I will dictate that. But anyway, you know that basic points only. What is isotone, right? So this is size of the nucleus. Tomorrow or next class we'll discuss about binding energy and mass defect. Clear? So MPC student, you leave the session of this and you join in your next class of yours MPC. And BPC student, you stay back. So after 5 minutes, we'll continue the doubts. Clear? Right.